Hello, good morning. Thank you, Keon. Good morning,
No
everyone.
problem. Hey,
It's very, very
Morning.
good to see you all. I know behind all those boxes, someone is out there. So, good morning to you all. And yes, good morning in the chat. Hi, Daniel. Hi, good morning. And hello, I see more videos. Good morning, Bailey. Good morning, Daniel. Hi, Mehmet. I hope I'm saying that right. And Sanjita, good morning. Saja, I really hope I'm saying these names right. Good morning, everyone. And at any time, feel free to correct me if I say your name wrong. Um, oh, wow, so many unique names. Andrea, good morning. And oh, I don't, Hofi side? You'll have to show me. And good morning, Adam. And Nate, thank you for adding your name to the video. I appreciate it so much. Yeah. Oh, Hovsep. Okay, I hope I got that one right. Good morning, Brian. And good morning, Saja. Hi, everyone. Welcome to winter day one. It's fantastic to see you all. I spoke to many of you through winter and through fall, and I also see some familiar faces from my summer physics 11, from fall, and especially thankful for Keon. I was hoping I'd get his video this morning just so, hello. Just, it's nice to know someone in class. So I'll say that I have all my screens open and this will be normal for class. So I can see all of your boxes. I have the chat open and I can see everything in the chat. I can see all your reactions. So, feel free to use any way you want to interact with me. I really appreciate it and it'll make class better for you and for me and just for everyone as a whole.
Are we able to
And
like
if you'd
including?
ever like to send me, I see the thumbs up. Thanks, Adam. If you ever want to send me a private chat, it's totally okay. And towards the end of the class, when everyone maybe gets a little more comfortable, I might get a little backed up with the chats. So just kind of bear with me there. Um, yeah, and throughout the class, it'd be nice if anyone wants to turn their videos on or change their profile picture. I see Randy's picture and now I see Randy. Check that out. It worked. Good
Hi.
morning, Randy. I
Hi.
also see that there's a Niners fan in that house, so that's good. We'll go with that. um, so guys, again, I'm glad to have you all here. Happy New Year. Happy 2021. You're all taking a winter class, a 5-unit Physics 101 calc-based class. So I think that already says a lot about, yeah, it says a lot about you already. Um, we're going to try to make this as pleasant as possible for everyone. So, hello, good morning. We're going to make this as pleasant as possible for everyone. And I think the key throughout class will be communication. You know, if anything ever goes wrong, believe me, we can fix everything and there's a solution for everything. So, just talk to me about it and we'll figure something out always. So let me start with two kind of right off the bat announcements that I think a lot of you are probably wondering about. First, if you're not officially enrolled in this class, do not worry. We will get you enrolled. It might take a few days just because everyone is back today. Um, be nice to everyone in emails. It goes, it helps a little bit. But we will get you enrolled. As long as you have the Zoom link, you should be okay. And just kind of keep in contact with me until we get you enrolled. And I will give the permit numbers to anyone who needs it at the end of class. But I do have them ready to give. So that's my second announcement. When is the end of class? So
6:05.
first I'll say I can't talk for that long and my voice goes right away. So I will depend on you guys for interaction, but I just really can't talk that long. So today I expect that we'll be done around 12. I think the intros will take maybe 30 to 40 minutes, um, answering all your questions. Oh, Randy, I can't hear you. Oh,
Now you can
oh,
hear?
my volume is up. Check your side.
Can you hear me now?
Nope, can't hear you. Wait, you
Huh.
know what? Let me triple check. Yeah, my volume
I
is.
I can hear you.
I can hear him.
But you guys can't hear me? Wait, you can't
I
hear
can
me?
hear you.
Oh, Randy, I can hear you
Yeah,
now.
I can hear
Yeah, you
you.
can hear him.
Okay.
Okay, we're good, guys. So I did this. Okay, thank you, Bailey, for also helping us out in the chat. Um, yes, Luis 12 also does sound great. I did this volume thing like maybe since Zoom has started. I've probably done it like 3 times where I forgot to turn my volume up, and I'm just talking for like ever, thinking that no one's talking back to me. But it's okay. That's my job to just talk. So I think we're going to end around 12 today. We will go over all of the intro stuff, maybe take a break. We'll see how everyone feels. And then we'll go over all of chapter one, which is not a lot, but we will do chapter one today. And then I will walk you through what is the homework for chapter one and the lab with chapter one. And I do think we can finish that around 12 today. Typically, we should finish around 12:30, including the lab, like showing you the lab, introducing the lab, giving you examples for the lab, and kind of walking you through it step by step. And then you're free. You're free for the next 6 hours, hopefully, to do physics, because that's what's on the schedule. And for most of those, for that block of time, I'll usually be available through email. So you can email me as much as you want, and I usually will respond pretty quickly. Um, After 6, I might not respond as quickly. On the weekends, I might not respond as quickly. Um, yeah, yeah. So those were the two major announcements before we start. I think we'll end around 12-ish today, and then you'll be free to continue the work on your own, and I'll be available to help. And anyone who's trying to add, just stay after class. I will tell you when I officially finish lecture, I'll stop recording, and then I'll work one-on-one with everyone to get you all added. Um, so before we go to the syllabus, any questions from anyone? It's so good to see all your faces. I appreciate it so much. And in the chat also, feel free, any questions. Um, if you don't have any questions, it's always helpful to, just thanks, Bailey. I see a thumbs up. It's always helpful. Oh, Randy, yes, we have a question.
It might be something you're gonna get to, but I was wondering about the book.
Yeah, I will get to that, but let's
Okay.
let's just talk about it really quickly. Actually, Randy, that was supposed to be my third announcement. Anyone, thank you, Keon. Keon's been in my class before, so he knows. Anyone with good internet that has a nice copy of the PDF, throw it in the chat right now. Put that PDF
Oh
up.
yeah.
Yeah, and guys, let's be resourceful. If you have the solutions manual, be a pal to someone in class. Throw it in the chat too. Everyone has it. Let's just make it easy for each other to help each other out. If you have a Discord, throw the link in the chat. Help each other out. I will, um, help you guys as much.
Does anybody or you use it's called Slater? That's a really helpful app. It has solutions step by step to books problems.
Yes, yes, yes. Later. Yeah, people. Yeah, if anyone does use it, use everything available online. I don't mind. We'll talk about exams later, but anything available to you online is available to me, is available to everyone. Share it with each other. This class is not curved. So can you all get an A? Yes. Yes. Okay, so that was the actual third announcement I was supposed to make. So I'm pretty sure someone, uh, yeah, guys, throw the links in the chat. Just yes for Discord. Yes, yes, do it. Um, I'm pretty sure someone is uploading, and it takes a while for it to load into the chat, the PDF. So just kind of hold out. Um, yeah, all of you, all of you join group chat. And then if all of you ever want to email me like one question from the group, I'm okay with that. Yeah, democratic process here. Okay, I got a private question for me. Did you take that Laker picture yourself? Why, yes, I did. This is actually the last game before the pandemic, before the shutdown. It was against the Nets. It was the game that we lost when AD missed the three at the end. And it was the best tickets I've ever had to a Laker game. And I was so excited and very determined to go. And I did take this picture myself. So you'll see this picture for a while. And if you join me in Spring Physics 102, we'll switch to the Dodgers background too, but not quite yet. Okay, so I think those are the major announcements. We're getting the book to everyone in the chat. We're getting some grip resources ready for you guys. Class should end today, I think around 12. Yeah, I think
Sorry.
around, oh, it's okay. I think around 12, and I will add anyone who needs adding, and I will stay after class and help anyone who needs it. So any other questions? All right, we got some links. Thanks, Luis, for being active in there too. Yeah.
So I found on that link, I found the ninth edition, but I couldn't find the 10th.
Ah, I see. So the ninth edition works. The homework is from the 10th edition. But usually as long as you like do some problems that are physics, I'm okay with it, you know. But we're gonna get you the 10th edition. It's uploading. I know
Okay.
it's uploading. You just hold on. It'll happen.
It's like 15%.
Ah,
It's
Okay.
just really slow, but it's
Big.
like 15%, 20%.
thanks, Kian. Yeah, it happens, especially because it's such a big file. Let me get a question from Daniela. Will we be using some kind of platform needing an access code for homework or labs? I think you might be referring to something like Mastering Physics or another program. No, everything in this class, or even like what is it, like Beyond Labs or any of those labs? No, I found all lab simulations that I like online for free. And so I will give you everything you need for the lab. Most of the labs you can also do on a phone. If there's ever a lab that doesn't work, let me know. Let me know. But we've been pretty lucky. The physics people all over the country have been working on nice simulations. So I'll have that for labs, and homework will all be out of the textbook. Yeah. So if you're following along on a phone or at home and you don't see the chat, Henry just put in a Discord link. Go join. I won't join. Don't worry. You go do your thing. Help each other out. Yeah. Okay. Any other questions before we look at the syllabus and probably get many more questions? Okay, I see none. So if ever also in the future, if I ask for questions and you guys are just good to go, you could give me a reaction and I'll stop asking for questions and just move forward. Okay, so let us get to our first shared screen. I actually, thank you, Jonathan. I actually wrote some notes. So let me triple check that I got all of that. Yeah, okay, we got everything. And I just want to, one more time tell you guys that I can see so much on I have a pretty good screen setup here. So even when I'm sharing the screen, I can see the chat. Even when I'm sharing the screen, I can see your boxes and the reactions. So please use them. I can see them, and, we'll bring them all into class. Okay, so thanks Adam. So did anyone notice that I uploaded, oh, Neil also, that I uploaded the wrong syllabus? Did anyone notice that?
I noticed the dates were I noticed the dates were like a little messed up, but
yeah. So welcome to my class. We're all human, stuff happens. um, well, I promise I have the right syllabus now. And yesterday or 2 days ago when I finished everything, the preview button was just taking so long for it to preview the file. And I was like, it has to be right, whatever. So I left it. And then today when I went to preview it, I was like, oh crap, that's not the right one. But I uploaded it. So if you're adding late, you're completely caught up because we're all going to see the syllabus for the first time. Okay, and so here, everyone, is our syllabus. If the screen looks a little bit small, let me know. I will zoom in, but you just have to let me know. And I'm moving all my screens around so I can see you guys. I can see the chat. Yeah, the dates were kind of off. You guys did notice, Daniela, too. Yeah, me too, but I noticed like 15 minutes before class. Okay, so I still can see all of you guys. I can see the chat. And so here's our actual syllabus. And let me move around my buttons. Ay, Dios mío, there's so many buttons. Okay, is this a good view? Can you guys see it okay? Should I zoom in? We're good. All right, thank you, Mehmet. I appreciate it. Thanks, Saja. I see you too. Okay, so guys, welcome to Physics 101. And this is our class. I hope we'll take a quick, oh God, these stupid things. Where's the mouse? We'll take a quick tour of the syllabus and then we'll go a little bit more in detail. I revamped all my syllabi last semester, so if you've taken me in the fall, you might have seen this. If you took me in the summer, yeah, not so much. All right, and Keon has a link for us in the chat. Check it out. Okay, so here's your first page of our syllabus. I really hope you take the time today, tomorrow, sometime this week to read the syllabus in detail. It really sets the tone for the class and hopefully welcomes you and gets you into the spirit of interacting in our Zoom class. So the first one will really kind of set the tone, give you the mindset of what it is we're doing in physics, what we're trying to answer, and we're always trying to answer questions in this class. The second page, the top half, will really give you some study habits that should work. They should work. And usually when you ask me for any additional help, I will refer to these study habits right away. So if you can't get a hold of me or can't get, some study habits that you need right away, read the syllabus. You'll see the description of the class of Physics 101, and I'll talk more about that when we talk about chapter 1. And then you'll see the important dates. We'll go through those in a second. The one you really want to see is my favorite, the day we get off, which I think is not next Monday, but the following Monday. Yeah. Okay, and then you'll see some great information, and we'll go through that too. Finally, some tips to succeed in this course. And, you're all taking Physics 101 in the winter, so I'm pretty sure that a lot of you, have some of these already in place, some of these tips and habits in place, because this isn't an easy thing to do in the winter. So we'll go through this and again emphasize that this class really is a learning community, and we got to help each other out here too. And you'll see a few more resources although, you know, the links are more important now than ever. And if you ever need anything at Trade Tech or the district, I know so many of you are not from Trade Tech, but I can still help you. I can help you with anything, any resource you might need. And then finally, our timeline. And we'll spend a lot more time on this in just a few minutes. Yeah. Okay, so let me go back to the top. And I have a question for me. Can we use the Notability app to submit our work? Um, you can use anything you want as long as I get a PDF. Canvas will only accept a PDF. No documents, no OD, whatever, nothing. It has to be a PDF. So if you can use Notability and convert your work to a PDF, no problem. That works. Any way you can make a PDF. The Adobe Scan app is really good. If you have an iPhone, it'll turn pictures into a PDF really quickly. Everything in this class will be submitted into a PDF. The Cam Scanner app. Thank you, Daniela. That's another really good app to use. And you guys want to get comfortable with this because this is how we will turn in our exams. And so this whole week, you'll submit several assignments as a PDF, and our exam will be as a PDF, kind of under a time crunch. So you want to get really comfortable with getting your assignments into a PDF and submitting them. Okay, so let me start at the very top of the syllabus. And yes, Adobe Scan. Thank you, Kian. Yes. If you have any questions throughout me talking about the syllabus, stop me. Feel free to throw it in the chat. I'll do my best to get to it. I'm going to go through the major points of the syllabus, not line by line, and then we'll review a little bit. What I really want to look at is this beginning part. So first, to make sure that all of you are in Physics 101, physics for engineers and scientists, or physics for scientists and engineers, the right way to say it. And this means that all of you are interested somehow in STEM, either a computer scientist, a chemist, perhaps you want to go into like med school, pharmacy school, or perhaps you want to be an engineer or a physicist or astronomer. So in the community college or civil engineering, yes, I see it. In the community college system, the lower division of most of these STEM majors are all the same coursework. And the foundation to many of these STEM majors are physics and math. So those are your priorities. Finish your math, work on physics, and then work into your major courses. But the one thing I want to make sure you all know is this is not Physics 37. Okay, Physics 37, 38, and 39 is also a 3-course sequence of courses used by the district at some schools like Harvard, but I think Southwest too. But okay, but they do not equate. 37 does not equate 101. 38 does not equate 102. So you really want to make sure if you're trying to like take one from different sequences, like 37 and then 102, you really want to make sure you're working either with the instructor or with your science counselor that knows the topics within the course, because it's not very easy to do. It can be done, but you want to save yourself some trouble for when you do transfer and you're appealing for any course, which is normal process. You just want to make sure that you did your homework on it and you got all your categories covered. Okay, so we're all in Physics 101. The COREC is only Calc 1. At different schools in the district, there are different prerequisites. So at Trade Tech, we changed the prereq of Physics 11 to only be an advisory. So if you've taken Physics 11, you're going to be very familiar with some of the topics, and that's great. If you haven't taken Physics 11, I teach the course as if you didn't take Physics 11 and all of this is new. So either way, you'll be okay, but you do not need it for the class at Trade Tech. Okay, I see a question in the chat. So you can't take 101 and then 38, for example. So I don't want to say you can't, you can, but you really want to make sure you're working with your goal university that you want to transfer to, and the physics instructor that you're kind of taking, because they know the exact translation of the class. So I can tell you, for example, one of the schools, I think either Valley or Mission, the physics 38 is not equivalent to physics 102 with me, because they move their thermo into one of the other classes. So that's one example. If you transfer and they look for where you took thermo, it will not be equivalent. You can, but you really want to be careful of what topics are in each class.
Professor Lee,
Yes.
can I answer her question?
Oh, yes.
So for schools like the UCs and like USC, if you're a STEM major, they told me you have to do the 102, 103, 101 sequence. You can't go back and forth between 37 and whatever. They're not the same.
Yeah.
So if you are a STEM major, you have to do the 101, 102, 103. I'm from West LA, and so I was in the 37, 38, 39. So they told me I had to change because it's not the same for if you're a STEM major.
Yeah, thank you, Bailey, and that's true, and you did the right thing by talking to the university. And I just want to put out there that if for some situations you might be able to get away with it, but in general you don't want to mix up the sequence. Yeah, in general you don't want to, just because you're going to have to go through some extra hurdles of appealing and talking to different people to make sure it's right. But if you're in like a tough spot and you need to do it, talk to people about it. But in general, no, you don't want to mix up the sequence. Yeah, that's it. And Brian has some really good advice too. Check assist for everything.
On assist, it says that what she just said, it must be taken as a series.
Yeah.
It has like a little asterisk.
Yeah, it would really require going like case by case for people who jump out of the sequence. It's gonna bring you a little bit of extra work. The last thing I'll say, dang, I forgot. The last thing I'll say, whatever, I'll remember it. But yes, do your best to stay within sequences. For math, that might be a little, also the same, but it's more common for STEM majors to jump in different sequences for math. But yeah. Anyways, y'all let me know whatever you have questions about. I know this stuff pretty well. So we're all in physics 101. Most of you will need 102. And actually, I think all of you will probably need 102. And then most of you will need 103. So we can talk in the future about the sequence as a whole, and just my advice in general on how to take it, where to take it. I will teach 102 in the spring. And so if the format of my class is something that works for you and you want to take 102 and it's full, don't worry about it. Email me, I'll take everyone. When we were in class, I would say, well, as long as we can find a chair for you, I'll take you. And then everyone would be sitting all over the class, but it's all good. I don't mind.
I have a question regarding that. So like you said the co-requisite of calc, and so that means you have to take it at the same time. But what if we've taken it prior to?
Yeah, it's the minimum is correct. So if you've already taken it, you've met that. And that's a good question, because I kind of really like winter physics 101, because this means that all of you have taken calculus, whereas in the semester class, most of them or half the class is usually in Calc 1. So imagine, kind of, we take a little bit longer on some topics, but can you take Calc 2 and Physics 102 at the same time? Yes, you'll be totally fine. The COREC is there for a reason. And in some classes at some schools in the district, they'll have it as a prereq, and don't let that scare you off. The state requirement is the COREC, which is why we were able to change it at Trade. So across the state, this is the way physics is taught, with calculus at the same time. And as STEM majors, we really want to get used to this load of rigorous courses with a little bit of fun in there. You got to take something else to keep you sane. Yeah. Okay, so we made it to line 1 of the syllabus. Let's keep going. So my class will be every day, Monday through Thursday, and lecture will be 10 to 12:30. I start class on time. I end class on time. That's about it. I start on the dot, I end on the dot. I'm not gonna, when I go over, I'll ask for your permission. But I try not to go over. And I also am very punctual. So yeah, we will start on time. So do your best to come to class on time. And again, our lab will mostly be done, on your own time, but there is the allotted time, for example, 12:40 to 6. So should the labs and the homework and everything take you about, 5 to 6 hours, yeah, it's a good idea to spend that much time working on it. Yeah. And so everything, of course, will be done on Zoom. This is our platform, at least officially from the district through the fall. But, things might change, we hope. Um, and I have a question to me. I already took Calc 1, 2, and 3. For Calc 3, I know some formulas for vectors like torque as well. Will we use these kind of formulas? Yeah, this is a calc-based class, so we're gonna use all of that. Torque is actually my favorite Physics 101 topic. I like everything in Physics 101, but torque, man, wait till we get to torque. I think we'll see it in week 4. Yes, we'll use all that stuff too.
Did you just say fall? Fall of next year?
Yeah. The way that you feel is the way that I felt when I heard fall, because I felt like it was snuck in there. Like all of a sudden we went from, for sure we'll be on Zoom through spring, and then all of a sudden the general language is through fall. And I'm like, what? Like, when did we announce this?
My whole degree is online.
Yeah, and I guys, it sucks. It does suck. I'm with you 100%. But if you're able to progress even a little bit throughout this pandemic, I'm really proud of you for doing that. And it makes me want to still be here, because this, like many of you, is not what we signed up for, So yeah, so we'll do our best to get through it. And let me also say, and I promise I'll keep going, but for the first page, this is pretty much it. This class is not meant for you to leave with a mastery of physics. I'm not going to try to, make you prove like, I don't know, solve a problem to win a Nobel Prize in physics. That's not what this class is. That's not what we're going to do in 5 weeks of winter physics 101. I want you to become familiar with the topics, and when you get an A on this in this class, or a B in this class, that means that you fulfilled the tasks in the syllabus. It doesn't necessarily mean that if you got a C that you suck at physics and you'll never do physics again. No, it means we're in a pandemic and you're trying to get by and keep going and get familiar with topics. That's it. That's all we want. So. We'll get through it, but to be honest, I have some very high hopes for fall. I feel like fall might be okay. Yes, I do save on gas. Actually,
Fingers crossed.
Yeah, fingers crossed. I'm very, as a, as a science person, and I read all the literature out there, I'm very hopeful for fall. Very hopeful. I think it could happen. We'll see.
There are 3 vaccines now, so
yeah.
They say that the like general population will be able to get them at the soonest at like summer.
Yeah, and the vaccines, for example, that third one doesn't need the super low temperature, so that's some improvements. And okay, last thing I'll say, I promise I'll move on. When all this started happening and the medical field was saying there's no way we can get a vaccine, on average it takes 10 years. That's very much like a different perspective than someone who would be in research and would have a PhD would have. And I right away was like, no, we'll get it within a year or two, because when scientists have to really solve a problem, it becomes about you guys hear the cops? Yeah. it becomes about solving the problem for people, for humans, and it becomes about sharing information, which is what science should be. So okay, I think they've passed. I'm in downtown, by the way. So yeah. That's I hear all the gosh. It's okay. I get distracted. So yes, I knew for sure the vaccine would come out because you have the entire world now collaborating on something, you know, so it's gonna accelerate the process. So go science. Yeah. Okay, so our syllabus. Like I said, we start on time, we try to end on time, and I do plan for these side conversations. They are in my budget of time, so don't worry, we will start and end on time. This class is 5 units, and what that 5 units really means is that you have to dedicate quite a bit of time to this class. The general rule and how units in across the state are assigned to classes depends on how much time you should commit to the class outside of class. So our lecture is about 2.5 hours. So you should spend an additional 2 hours outside of class for every hour you are in class. And that sounds like a lot. And for winter, that is a lot. So that's why you get a heavy, higher unit for this class. So it means you should dedicate time. And I always got to say too, that 5 units for physics is the same as 5 units for calculus. So as much time as you dedicated to calculus, you should be dedicating to this class, even if, you know, maybe I may seem a little nicer and, you know, a little more lenient, sure, but 5 units is still 5 units. So, yeah. Okay, so you should all have Calc 1 done. And if you don't have Calc, or if you don't feel like great about having Calc 1 done, we're going to go through it, you know, as if you were in Calc 1 now. So feel free to stop me at any time. But I will also depend on you guys for calculus information because I don't memorize it. So if I forget a derivative, if I forget an integral, you let me know what the answer is. And Keon's book has just appeared in the chat. So thank you. You guys all out there, go download from the chat. Okay, so while you're all downloading, I'll say the last part of really important information from this top of the syllabus is my email. And that is the best way to get a hold of me outside of class. I very much encourage you to talk to me during class. If it's a, you know, individual situation, probably after class is best, but email me for anything you need. Don't wait till the last minute. Yeah, don't wait till the last minute for really important stuff like this that involves other people usually. You know, if you're like other things, sure. Okay, so let's see. I have office hours 8 to 10, but it's really, you know, you email me and we can set up a Zoom meeting anytime you'd like. I like to do it like 15 to 20-minute sessions. But if you have a question, feel free to email me. If you can hang around after class, that's the best time. You know, yeah, that works too. But there are office hours, so feel free to email me and we can set it up. Let's see. So again, Physics 101, we're gonna look at everything around us and put physics behind it and put math behind it. And that's the next thing, that everything we do should somehow be supported by physics and supported by math. So physically and mathematically, everything we do should be supported that way, including, you know, the buildings you see in downtown LA, why they're standing, why they're able to stand through an earthquake, what are the forces acting on them. We can talk about that physically, but we can also prove that mathematically. And that's what we're gonna do in this class. Let's see. So please take some time to read the syllabus throughout the week, for sure by this week. Things about our class in general. Ask a lot of questions, you know, ask a lot of questions when you're uncertain about something. Ask as much as you want. I generally repeat things 3 times. So feel free to ask as much as you want. I will, if I have to repeat, I will, but just ask anytime you have a question. If you don't feel comfortable asking, you can do it privately to me in the chat. That always works too. I will, because of Zoom, everything's on Canvas, and I will try my best to put as much detail as I can in the assignments in the assignment description for Canvas. So do always read carefully the assignment. Everything you need to know should be in there. And I'll show you on Canvas what that looks like too. The thing I'll say about this class though is that I very much want you to explore and be creative the entire class. So sometimes you won't see a description for how to complete, if I ask you to do something at home, I can't give you a full description of how to do that at home. I expect you to be creative and explore and talk about what that process was like. But as much as I can, I will give you some description or at least an example in class. Let's see. Of course, come to class ready to learn. If you're able to log on to a computer and sit at a table, that's really great. But if you're at home, like on your bed, that's really great too. But if you have the option to sit at a table with a computer, please take that option. Please get out of bed, get ready, come to class, make yourself some coffee, do that. It'll be a whole new experience for you if you are not in class, like oh, you can't see my phone, but if you're just staring at the phone like this watching. I've seen this in lecture. Yes. Put some clothes on too. I've seen that too. Yeah. Okay, so yes, come to class ready and learn and engage in class. And work together. That's huge in this class. Please, no assignment is a group assignment. They're all individual, but can you work as a group on, to get things done? Yeah. But will you each have, your individual assignments? Yes. But do what you can to get by in this class by working together. I very much support that. Let's see. Okay, I'll let you read your approach to learning, and we will go over this course description and learning outcomes a little bit more in chapter 1. I have about 20 minutes before I get off my schedule here. So course description. So what's really nice is that if you took Physics 11, you would have seen all the topics of physics, most of the topics from Physics 101, 102, and 103. But usually in Physics 11, equations and formulas are kind of handed to you. In Physics 101, 102, and 103, we're going to try to derive those, and we're going to try to just come up with relationships of how things exist based on what we physically see, and then try to throw some math behind it. Physics 101 is all about motion that we can see with our eyes. Physics 102 is about motion that we can't see with our eyes. And Physics 103 is about motion, light that we kind of theoretically think is there, and we have some physical proof, but there's a lot of theory behind it. So Physics 101 is all motion. We'll be talking about motion in different, we'll build up to different parts of motion throughout Physics 101. Let's see, important dates. So make sure you get everything you need for this class by Wednesday. Wednesday is also the drop date for this class. So if you're not active on Canvas by Wednesday, I will personally drop you. So just make sure you're at least logged onto Canvas. Now, if you're a person who's trying to add, I will cross-check that with my email and make sure that I know, you're still trying to add, so you will not be dropped. But yeah, just make sure you're active on Canvas. Let's see. I'll remind you about this date too, the last date to drop with a W. If you end up dropping the class, I really hope you talk to me first, and I will kind of give you my advice or suggestion based on what's right for you, not what's right on you staying in the class. Especially in winter, you might start the first 2 weeks all excited, and then you're over it, and that's okay to take a break. So, or if something goes wrong in winter, it's unfortunately really hard to recover in 5 weeks over missing like 2 or 3 days. So, we'll have to talk about it, but the drop date is January 30th, and I will remind you all. Okay, we won't have class on the 18th, and that should be on the syllabus. And I'll also, I'll remind you, and I won't show up to class. So, someone will click on the link, and I will get an email notification that someone showed up. Well, you know, it's all good. Um, okay, our final exam will be the last day of class, which means that we will have an exam on Monday of the last week of class and on Thursday of the last week of class. Does that sound impossible? Yeah, that kind of sucks. But I've done this before. I will work out the schedule and I will prepare you to be able to take a test on the last day of class. And I know this is coming. Is the final exam cumulative? No, it is not. The final exam is not cumulative. The final exam will be based on the last few chapters that we do, and that's it. But there's a trick in there because the last few chapters are based on the whole course. So, you know, one way or another, you gotta keep up. So this is our book. We have the PDF in the chat. I'm glad. But you know, physics is physics everywhere. So if you have another book, it's okay. You know, I'll upload my slides always before. I kind of think I really like my slides. So they're, I made some changes from the publisher slides. So if you are just going from the slides, that's okay too. But the book is really, really helpful and detailed. Everything for the lab, I will give you. Yeah, everything for the lab, I will give you. Yeah, so everything will be on Canvas. And a question from, oh, we have two questions. First one, is thermo part of the 102 course that you teach? Yes, thermo is part of the 102 course that I teach. And I do my best to get through thermo as fast as possible because I don't like it. I like electricity and magnetism. And then a question from Daniela, is the final exam, exam 5? Yes, yes it is. And again, I've done these short courses several times. I'll get to you, Randy. I've done these courses several times, so I will prepare you for it. Do your best not to freak out and know that I will prepare you for exam 5 in 3 days. Randy, you have a question? Unmute.
Can you hear me now?
Yes.
So that means like there's a test every week. Is that always going to be on a Thursday? And
no, and I'll show you right now on the schedule. Every test will be on a Monday, and
Monday.
Yeah, every test will be on a Monday, and I will get to Luis's question next. Every exam will be on a Monday. I'll show you on the schedule kind of the way I'd like to plan things out, but the goal is to give you the weekend to study for the exam. Yeah. Luis, you want to unmute?
Yeah, I had a question about what times the exam would be on the Monday.
Yeah, that's where I lost my train of thought. What it was. Thank you. Luis, so the exam will usually be at 10 a.m., which is the beginning of class, and it'll be 1 hour. And I will give you all the details about how the exam will be structured, probably on Thursday to prepare us. But know that you will be ready to take a 1 hour exam. And then, to everyone's excitement, we will come back to lecture for at least 1 hour. And you'll hate me now for it, but you'll thank me later for it when, you know, it's not, it'll help. I promise it'll help. The one thing I do on Mondays to kind of alleviate your time after the exam is that we will not have a lab on Mondays. So Mondays will be exam, a little bit of lecture, and then you do whatever you want. Yeah. Okay, so I'll get to the details on the schedule. We're almost at that page. So here's the grade breakdown. Neil says how many exams in total. So 5 exams. Destiny's asking, are we logged into Zoom for exams? You should be, but am I going to force you? No. Am I going to fail you? No. But should you be? Yes, because you will likely have a question during the exam, and I am available to answer those questions during the exam. Yeah, and if I miss something on the exam, I'll announce it through Zoom. Yes, Luis says electricity went out during the exam. In fact, everything goes wrong during the exams. You know, everything goes wrong during the exams. We will get through it. It's okay. As long as you communicate with me, as soon as you can throughout the exam, we will be okay. Um, yeah, yeah. So on Thursday, we'll go over those details like way more, just to remind you too. Okay, so grading for this class, you'll see that it's about 25% any assignment like homework, equation sheets, all of that will be 25%. The labs will be 25%, and your 5 exams will be about 50%. Do I give like partial credit? Yes. Do I give extra credit? Yes. Show all your work on everything that you do. I will emphasize that over and over. I'm a very detailed grader. I will look at every I that you dot, every T that you cross. I will look at it to try to figure out what was happening. So show all your work. I have a general, grade distribution. I don't curve the grades. You will not be tested against each other. I will round up. If you get an 89.945, something like that, I will round it up. Let's see. Yeah, pretty much. Yeah, let me do something super quick here. Do you guys?
So like an 89.9 doesn't round up to a 90?
It does. It'll round up to an
Okay.
8. It'll round up. I should clarify that this is for the final grades. For the final grades, I will do that. But yeah, it's usually okay. Let me talk a little bit about this. Now, homework is from the textbook. Homework I expect you all to do and turn in and have it done. So everyone should get 25%. So if this is the bar, right? And this is a 0, and this is 100, and this is an A in the class, the homework is something that everyone should be able to do without a problem, which means that 25% of your grade is already complete. And the reason I say that everyone should be able to do this is because the solutions to all the homework is online. I will post the solutions after they're due, but everyone has access to the solutions online. So really, this is an easy assignment. You should be able to get those first 25% of your grade. The next one is the labs. That's another 25%. The majority of the grading of the labs will be completion, making sure you complete every part of the assignment of the lab. So sometimes when there's some labs that have a report and some labs that do not, it'll be very clear on Canvas. So making sure you complete the 3 sections of the report, or just making sure you complete all of the questions that the lab manual asks. So I estimate that everyone should be able to get at least an 85% on all of the labs and above, which is, pretty close to filling that next, oh, that's not 25%, pretty close to filling that next 25%. So you should be somewhere, after the labs, you should be somewhere around 45 to 50. Now the rest is all the exams. And again, I'm a very lenient grader. I'm always going to grade on your side, which means you want to show as much work as you can. And if you do not show work, you will lose points. And I'll tell you in detail on Thursday before the exam day, the other things that I'm going to emphasize on the exams. So you have 5 exams. The first one should be, the easier of them all. And then they might get a little bit harder. And the exams, the questions are going to be very similar to the homework. There is no study guide. There's no practice exam. Use the homework. I cannot emphasize that enough. Use the homework to study for the exam, because when I write the exam, and I do write my exams like the night before, because I'm a softie and I'll tell you all the questions. I write the exams the night before, literally looking at the homework and just coming up with questions based on the homework. So do the homework. And even if you run out of time that week and copy the homework all down from a solutions and submit it, study it, at least study it for the exam. And then you can get pretty close. And I think everyone can get, I expect 80s and above. That's the goal. If you don't do so well on an exam, it's okay. It's okay. There are 5. Let's see, a question from Daniel. Does that 50% for exams include the final exam? Yes, it does include the final exam. Is the final weight the same as the other exams? Yes, the final exam is exam 5. So here you have exam 1, exam 2, exam 3, exam 4, and exam 5. They're all equal. My picture is not to scale. Shut up, Keon. I see you laughing. You guys will see my beautiful artwork throughout the semester. Yes, so 10% each exam, even if they're not equal on here. So you have a lot of wiggle room there. But really, I expect these labs and homeworks to be done, and that's really what gets you 50% of the way. The rest is exams. So let's do worst case scenario. Imagine that you do all of the activities in labs. That's 50%. And imagine that you get a solid C on every single exam. That's what, 75%, right? Something like that. So you would get 75, 75, 75, 75% out of the 50%. Don't do math in public. 0.75 times 50 is 37.5 points. So if you do 25 points of homework, 25 of labs, that's 50 points, and you get a solid C on every exam, you can get an 87.5 in the class, but it's 100% based on you doing your homework and your labs. So get that done, and you can still do well in the class. And then questions. Okay, we're getting detailed questions here, and I promise I will go through details more on Thursday again. But we're almost there anyways. Let's see. How long are we usually given to turn homework? Is it usually due the day it is assigned? And will the exams be open book, open note? Everything in my class is due on Friday by midnight, every single thing. Yeah. So how you distribute that time is up to you. I encourage you to do the homework and the lab the same day I talk about it, because it is not going to be a good Thursday, Friday for you if you leave it all to the end. But yeah, everything is due Friday. And then will the exams be open book, open note? Officially, the exams are not open book. And officially, I will let you have an equation sheet of notes that you will also submit for homework. Unofficially, I'm not stupid and neither are you. We know that we're on Zoom and everyone's doing who knows what, Will that show on your exam? I promise you it will show on your exam. Yeah. And
what do you mean by that? It will show?
Yeah, so every semester when I post my exam, someone posts it on Chegg right away, and some people will copy it and put it on the exam, and it shows. And it shows because half of the time the Chegg answers are wrong. And the other half of the time, the way I grade the exam will not be in a way that Chegg will show you it. So you can really tell when someone is copying solutions online. Will we have a conversation about it? Yes. Will I hate you? No. Will I fail you from the class? No. We will have a conversation. Yes, Randy.
So my question is so we all intend to take further into this series. And so would doing something like looking at notes or looking at a book put us at a disadvantage when we were to take a 102, or say if we had you again for 102, is there professors that are, and we were in class for a 103, would we then be required to know these formulas that we were before able to look up? And is that going to give us like an F?
Yes, so some details will vary instructor to instructor, and there's no way around that, The philosophy for me behind having an equation sheet and is that we can look anything up that we need, right? And I want you guys to memorize things. I want you guys to learn relationships between things and how to make some connections that will make things familiar. That's not the same in every class. But the foundation of being able to, you know, recognize a formula or know when something is needed, that will help you from class to class. I don't know any. It's really tough if you have an instructor that doesn't give you any exams. My bachelor's is in physics from UCLA, and I always had either an equation sheet or the equations provided for us. I don't remember ever having one where I had to completely memorize everything.
Oh, okay.
Yeah, because usually in science we have like a reference book of some sort. Yeah. Okay. And the last question from Daniela, or not, it's not last, but for the equation sheet, are we writing our own? Would we be given one? You're gonna write your own. It's going to be an assignment, and the assignment will have a full description of the equation sheet. And I will also talk to you about it on Thursday. So we'll go through all those details, but yeah, you will have something to help you out. Yeah. Okay, I think we'll get more of these questions as we go to the last page or so. So this is tips to succeed and resources. And unfortunately, every semester, and I really, please read this. If you read anything from this syllabus, read this page and read the growth mindset versus the fixed mindset. This is my timer just went off, so let me give us 15 more minutes. Yes, thank you, Randy. My whole philosophy in life, not just professionally but personally, is to live by this growth mindset, and you'll see it perhaps in everything that I do and the way that I teach and speak to you all. And maybe that's even what brought you to my class, because many of you are not from trade, and I welcome you all. But this is my philosophy of life. We teach it in our Engineering 101 course, which is, I also teach engineering classes at trade. And I yes, if you ever have a moment to read more about the growth mindset, do so. It'll and if you really try to follow it, it'll change the way you look at things and perhaps bring a little bit more peace and clarity to your life too. Especially now.
Yeah. Oh, professor, if I could, yeah, I didn't believe you when you said that last semester when I took engineering 101, but it really did, and I really did have a negative attitude about just trying to get away with doing the least amount of work in class, and it's like we make a choice to be here, and yeah, and it's really changed my outlook a lot.
Yeah, thanks, Keon. And it shows in students, which is why I tell you, if you cheat on an exam and you and I have to have a conversation, it doesn't mean that I'm not going to write a letter of rec for you in the future. It means we have to have a conversation and kind of see what do we need to change, right? And this mindset of going through your courses, especially now in a pandemic and being remote, can really bring a little bit of calm to you. And if you suffer from anxiety, it can really, really help things out here. So take a moment and read this. And whenever you get overwhelmed by this class or by material or anything, take a look at the syllabus. I think it'll put you at ease a little bit. And unfortunately, I have had to use this so much, this academic dishonest policy in our remote learning. And again, ultimately, you're not hurting me. You're hurting yourself if you're cheating in any way, because it catches up to you. That's really what happens. Either an exam for a job or an exam for, grad school, or you have to, when you're getting a grad degree, you have to perform, and there's no way to look up a solution there. So I get it. It happens. Everyone does it, but you want to minimize it. Okay, and so here's our timeline, and I'm going to quickly go over the first week. And just a little bit of heads up, we will take a break in a few minutes after I finish the schedule, because I got to use the bathroom, and I'm sure all you do too. I see a lot of cups of something. So we'll take a break in just a few minutes. Okay, so here's our schedule, and you'll see that the schedule pretty much repeats itself for the next 5 weeks. And this is what it'll look like. Every week we will have 1 to 3 chapters. Some weeks that'll vary. And some weeks it'll vary in that I might cut out a chapter that we're gonna cover somewhere else, and I'll give you a heads up when that happens. It usually happens when I just know we're not gonna, we're not gonna get a good grasp on this if we rush through it. So I'll move things around, and I'll tell you when I move things around. And I will only do it if it benefits the class, but if it's possible, like if it's not going to hurt you in the future, then we'll skip around a little bit here and there. But the goal of this class is very much to prepare you to take other problem solving classes, and to be prepared to take Physics 102, and to be prepared to take statics or dynamics if you're an engineering student. So we'll keep that in mind. So first week is chapters 1, 2, and 3. We will do chapter 1 today. We'll do chapter 2 all tomorrow, and chapter 3 the next day. And the goal in every week is to try to make it so that we have Thursday free, so that in class we can review major topics and do some problems together, and I can prepare you for the exam. That's the goal. We usually make this goal. We usually get there. Sometimes, Wednesdays will get a little rough and we'll leave a little bit over for Thursday, and that's okay. We'll still have time to review for the exam. So our goal is to try to work hard, especially Tuesdays and Wednesdays, so that we have Thursdays ready to review. And let me also say that Tuesdays and Wednesdays will be the rough days of this class. We're gonna not Monday, because Monday we still gotta wake up. Tuesday, Wednesday, we're gonna have a chapter, a lab, some work, and then Thursday we'll try to catch up and figure out, get our footing straight there. And so every week you will have a homework per chapter. I'm probably not going to put them all up until we do that chapter, to not overwhelm me or you, but you can expect one homework per chapter. The homework is usually about 5 to 10 problems, usually about 6 or 7, but anywhere from 5 to 10 of the textbook problems. And everything will be due Friday by midnight. Can you turn stuff in late? Yes. Will you get some points deducted? Yes. But turn it in late. Better late than never, right? Better to get a 90 than a 0. So do that. So every chapter will have a homework. I am shooting for 2 labs per week. Those 2 labs will usually be on Tuesday and Wednesday. And it'll usually be, the important topics. So we do have a lab today, but depending on the time, I might not get to it, but if anything, we'll just start with it tomorrow. But we do have 2 labs this week. So the goal is 1 homework per chapter, 2 labs per week. That's the goal. We'll see. And our other goal is to try to finish the chapters by Monday, Tuesday, Wednesday, so that Thursday we can review for the exam and just kind of, see if anyone has any questions and what can we go over in detail, some tips, things like that. These lab titles are really here to like official titles. Like when I have to send this to like UC San Diego, their titles match our titles, but our actual titles are a little different. For example, this one is units at home, but it's this stuff that you'll be doing. But you can expect that it'll be somewhere in this topic. Let's see. So we will have an exam every Monday. So you'll see exam 1 on Monday, and then you'll see that we're going to try very hard to start the next chapter, at least 1 hour in class. At least 1 hour, 12:30ish to try to finish. Let's see. Okay. And then the only thing that'll change is Oh, I guess I see two things. One is that week 3, we have that Monday off. So this week might be a little rough, but I will say that chapter 7 is very short, and chapter 9 is also very short. So we'll be okay. And then finally, the last week, we will have our normal schedule of exam 4 on Monday, and then on Thursday we will have exam 5. And right now it's set up to be these 3 chapters, but I usually have to skip one of them. I usually end up having to skip one of them. So I will tell you that you will see oscillatory motion in Physics 103 completely. And you will also see a little bit of it in chapter 13. So it's not like we'll miss a lot. Yeah. Okay, questions about the schedule?
Professor?
Yes.
So does each lecture have its own lab? Just to clarify.
No, each lecture won't always have its own lab, but there will be a lab twice a week, and I'm going to try to keep them on Tuesday and Wednesdays.
Thank you.
Yeah. So Monday, the schedule will be exam, lecture, and you leave. Tuesday, lecture, lab. Wednesday, lecture, lab. Thursday, maybe a little lecture, review for exam. And that review for the exam can include, talking about any of the labs. It will always include any questions that you may have. And I will always stay on too if you have any questions, if you just, want to talk. It's okay too. Yeah. Okay, thanks, Bailey. Okay, can I stop sharing the screen, or does anyone else need to see something from it? I lost my Zoom. Thank you, Mehmet. I see the thumbs up, but oh hell. I muted myself looking for, I got it. Amir, thank you. I see you. Okay, so I'm back to you guys. And I just want to ask one more time if there are any questions in general. This is the intro. Our intro is done. Any questions about intro, about logistics in general? Anything I can help you with? Randy, I see your hand up.
Do you teach English 1, or do you teach Physics 103?
Fun fact, I did teach the English version of the GRE many years ago.
Oh, okay.
It was for math and science students. Can you ask that again? Did you say Physics 103?
Yeah.
I taught Physics 103 last summer, and I love it. It's actually where most of my expertise is in. But usually at Trade Tech, Dr. Moreno teaches Physics 103. He's our chair. And that's really his territory. I have Physics 101 and 102. But last summer I was able to wiggle in to Physics 103. So I always try, but it doesn't always happen. But if I do, you all will be the first to know.
Okay.
Yeah. And if not, we can discuss in Physics 102 what you should do for 103. Yeah, we did that last semester. It's pretty helpful. I see a question from, I hope I'm saying this right. Ila? Oh, I can't say. Isla, thank you. Isla. Is Physics 103 a good course for the summer? I really enjoyed Physics 103 for the summer. More so than I usually teach Physics 102 in the summer, and that's rough, but we get through it, but I liked it. Yeah, it would be good timing for you guys, and believe me, I use the argument of completing the series with an instructor. It depends on a lot of like internal factors, so it depends on enrollment for the future, really. But I will say that when I taught Physics 103 this past summer, half of the class were UCLA USC students. I was really surprised. People said they wanted it, and only like 10-15 people from the district signed up. And then it was all UCLA USC. And then we had like, yeah, man, it was a like a Trojan land, and I was not happy. So it was okay. Randy, you had a question.
So how there's the co-requisite for for 101, is there a, like if I were to take physics 103 in the summer, do I need to have had calc 3 prior to taking it?
That's probably part of why people didn't take it. That yes, you will. The COREC is Calc 3, and depending on who teaches it, they might be able to waive it. So I was able to waive it for a few students, but with the like we had a conversation. I had a one-on-one conversation with every student I waived it for, that they would have to probably do a little extra work to catch up with the differential equations that was needed at the end of the semester. So that's why Calc 3 is needed, is when we get into the quantum part. Yeah, but a conversation to have with every instructor, especially if you've done well in other 5-unit classes, it can happen.
There's 2 like sessions in the summer, so I could do the calc 3 and then the physics 3, or is it a 10-week class instead of a 5-week?
When I taught it at Trade, it was summer session 1 and it was 5 weeks. And I gotta be honest, it's not very common to have physics 103 in the summer, which is why I think all those UCLA USC students joined the class. So I'm not sure you'll find it. But we'll look in the spring and see what happens. And then, yeah, so this was I was saying that because of Isla's question, will they have it this summer? Yeah, it's not very common. I had one student tell me that he looked through like the whole state of California and only found it at the the class that I was teaching. So I don't think it's common. Perhaps there's an argument for us to have it again. I would love to, but it's a process. So yeah. Okay, my timer went off again. Do we have any questions? Yes, Randy?
I do. I have another one. This is kind of like I'm not trying to sound lazy, but so my Calc 1 class, like I spent I feel like all day, every day, the whole semester doing work for it. And that's why like in the fall, I'm super nervous, or in the spring, I'm super nervous to have 102 and Calc 2 because it took almost all of my time, just Calc. So like, is this class going to be the same? Like, I mean, I understand it's a winter class, so probably it's going to be all day, every day. But like, I feel like if I had Calc in the winter, there's no way, even doing it all day, every day, that I would have got finished with what I had to do.
In the winter, I wouldn't advise anyone to take anything with Physics 101. So if you're working, you're going to have to really stick to a schedule. And I don't encourage it, but 100% I will help you in any way I can with tips and all that. But in the spring, Calc 2 and Physics 102 are the bottleneck courses that most students struggle with, unfortunately, but they should be taken together. Now, I hear this for many people with calculus, that you end up spending so much time on it, and I get it. There's a lot of homework. Yeah, and I think it comes from the homework. But
like the course itself wasn't difficult. Like I got a really high A, but it was a lot of work.
Yeah, and I know, which is why
Time-consuming.
my textbook questions are I only give you like 6 of them, but they are, they will be longer. There has to be some adjustment there. At some point, you gotta just give Calc 2 or Calc 3 its time, and that's it, because it shouldn't go past it. If any of you ever, like if you guys are planner people, you should stick to something called the 60-hour rule. And the 60-hour rule should be all of your courses, the time that every course needs, 2 hours per 1 hour of lecture, plus study time, which is the 2 hours for every 1 hour lecture, and any other time that you have for something that you have to be at, like work. All of that should add up to 60 hours per week. If it goes past it, including commuting time, if it goes past 60 hours, there is not a high likelihood of succeeding, or you're gonna really hurt yourself somehow. So at some point, Randy, and for everyone with calculus being this way, you really gotta just cut it, because I think you would have still gotten that high A. And Physics 101 and Calc 1 is meant to introduce you to this course load. So Physics 102 will be on the harder side. And Calc 2 is also the harder one. It's probably the one that I struggled with the most too. But you can do it. You can make a schedule for it. And, you know, in my physics class, I'm constantly asking what's happening in calculus. Tell me, you know, do we need to adjust the test date? I'm okay with that. In winter, not so much because we don't have any time. But in spring, I'm okay with that. We can adjust things, especially if you're all in the same class. But it's really something you gotta get a grip on throughout this, because once you get to upper division, you will be taking 3 to 4 science classes every semester or quarter. Yeah, but I'm happy to give you guys as many tips and make the schedule. Actually, in my physics 11 class, the 60-hour rule was an extra credit assignment, so maybe something we can we can look at here. Let me look at the chat really quick. Oh, Isla has great stuff. I had an awesome professor for Calc 2. His homework is on his YouTube channel, but he teaches at Pierce. If you're interested, his name is Steve Chow. Thank you, Isla. This is what I want to hear. Also, my classes last semester told me that Professor Leonard on YouTube is like the best in calculus. So if anyone wants to Google Professor Leonard, I have his tab pulled up because everyone across the board told me he was really great. Yes, Luis and Luis. Oh, we have 2 Luises. How cool. Luis and Luis agree. Professor Leonard is what I found out was the best resource. Let me see what else we say. Okay, so thank you, Isla. That's a great tip. Daniela, you wrote it down. That's what you should do, write things down. And then Brian, also, you would be less productive if you exceed 60 hours of work per week. So try not to hurt yourself. Yeah, and we got to learn that. So that first semester and reflecting back on it, Randy, is the right thing to do. It's really reflect back on what worked and what didn't work. And then Luis Garcia says, Professor Leonard on YouTube is amazing too. Oh, thanks, Luis. You had written it right when I was saying it too. Thank you. Help me survive Calc 1 and 2 over one single semester. Great. Oh, the OChem tutor. And Professor, also, do you teach Physics 102 over the summer? I don't know yet. I think so, but I don't know yet. And then OChem tutor has gotten me through some rough times. Excellent. Oh yeah, and anyone taking real analysis and physics at the same time, yeah, good luck. Okay, guys, I think we should take a break. And let me ask you all, is a 10-minute break enough, or should we go for 15 minutes? You can just put up a 10, a 15. You can let me know. Too little, too long. Okay, everyone's good with
10
10.
sounds good.
Okay, so right now, thank you guys. Let's okay. Let me give you the time to come back. Hold on, Kian. Let's do 11. Well, not 11:30 because that's 9 minutes. You know, let's go with 10 minutes. 11:32. Everyone come back at 11:32. I will also come back on the dot. 11:32. Hello. We're back. It's 11:32. Hello. It's good to see y'all again. Hi. Hi. Okay, good. And I hope all of you out there in the boxes and in the chat are all back too. Um, 10 minutes goes by so quick, huh? All right, I see the thumbs up. Thanks, Bailey and Adam and Mehmet and Isla. Esmeralda, thank you, Adam. Also, good to see you guys. Sanja and Hafsep and Alexandra, hello. um, all right, so we are back, and I'm going to kind of pivot a little bit to keep our spirits up, our physics spirits up. So I'm going to start chapter 1. We have about a little less than 30 slides to go through, which I promise is not a lot for this class. Usually a whole chapter is like a lot of slides. But yeah, so we'll do about 30 slides, and then I'll switch over to Canvas just to show you the homework and the assignments. And I see a lot of you with snacks. I love it. So this is what we would do in class too. If we were in trade tech in my class, yeah, I would tell you, hurry up and open all your chips, open all the bags, open all the wrappers, just so, you know, we get ready and we don't hear it. And then you have it available. This is the nice thing, that you can eat during lab in Zoom, when normally in lab, but the one time we really couldn't. Okay, so I am going to start my lecture slides, and just like, oh, okay, Daniel has a question. Do you also teach at ELAC online? No, I am 100% committed to trade tech. That's right, Keon. But I need to, but anyone can take this class, and I have had many students from all over the district the last few semesters. Actually, anytime when I taught this, when last semester when I taught winter physics 101, I had students from all over, because it's a really good opportunity to take a class and progress right through your coursework in a short term. So happy to have y'all here. I really am. So I do not teach at ELAC, but ELAC is part of the district, so I am available to you all. Okay, so we're gonna go with our lecture. Hello, we're gonna go to our lecture, and then we'll go to Canvas. And just like the first hour that you guys have been so active, I appreciate it. Luis, it's not that bad. Come on. Please continue to be just as active during the lecture. I promise you, it'll make this hour and a half much better, and you'll also hopefully, you know, grasp the material, so that when you read it after class on the textbook, it'll make a little more sense too. Yeah, okay, let me start my slides. Let me move things around, and again, anytime, let me share my screen and then move things around. Let's see. Okay, I think this one. Let's see. Okay, you guys should see a red car. Yeah, okay, great. I see the head nodding. Now let me move all you guys around, so I see all of you. Oh, I see the thumbs up. Thank you, Jonathan and Daniel. I'm going to move my screens so you guys cover my other screen, and let me get the chat box out. Okay, and the chat box is covering the other corner, and my Zoom menu is up top. Okay, so I should see everything, and let me get my little pen out. Okay, so again, let me start with saying that chapter 1 is very much a foundational chapter. It's all introductory and getting us ready to apply what we know, what we see physically in the world, and be able to put some math behind it. Before we do any of that, we need to start recognizing all of the physics that's happening around us. And we want to get to that point where we become, you know, people who can describe an everyday object using physics and math. Now, you don't want to do this out on the street, because then, you know, you might have a little trouble making friends. But you want to be able to know this in your mind and know, I know why those things work, you know, and then apply it in other ways. So a question to all of you, and you can unmute, you can write in the chat, you know, take your time. Tell me, what do you see on the screen? Anyone, anything at all?
Electric car?
Oh, okay. So first we see Randy comes with us, and please, anyone else, feel free to put in the chat because we're not done here. Anything you see. First thoughts from Randy, electric car. So my follow-up question is, what about this picture tells you that it's an electric car, Randy? And the answer is not right or wrong. I'm truly just wondering, what made you say that?
It's a little more sleek and it doesn't have an air intake in the front where the grill is. It's closed off. That's traditionally the style for electrics.
Yeah, I've heard that, and you know, when I show this picture, it's like maybe the second time I've ever heard that. And what Randy's talking about is this front part here. I also like that you also gave us the more you know, the more applicable answer. Hey, it's a little more on the sleek side, so perhaps this car is just a little bit more advanced, a little more elegance to it. Perhaps there's a little bit different work to it, you know. Thanks, Rand. And yeah, that's those are really good. And yes, I think it is an electric car. And Bradley says the ceiling lights. What about this picture makes the ceiling lights stand out? And anyone else? 33 of you. Let me hear at least 5 of you. Ah, okay. Hofseb says also the headlights too. Yeah, these headlights definitely do look different. They don't look as bulky, or there's more space inside under the hood, perhaps, to keep the headlights there. Anyone know what type of car this is? Yeah, I see lots of people that are looking at the car. That's like us. This is
I
us
think
all.
the manufacturer is Seat, like SEAT. I think it's a European car.
Okay, Amir says, am I writing this right? SE?
Yeah, CEAT. I think it's something like that. AT.
Oh God, I'm lost.
Like a seat, like a chair, like a SEAT.
Like this?
A. Here, I'll type it in chat.
Yeah, type in the chat. Oh, seed. Seed. Yes, I see it. Thank you guys. Seed. That's the name of the.
Oh, it is. That's what it looks like online, the logo.
Oh, okay. Oh, this logo right here. Okay, great.
Yeah.
Okay,
It
and
says it's a Spanish company.
Yeah.
And a European car. Okay, and someone else is telling me it reminds me of a Tesla as well. Yeah, so perhaps there's like this style of electric cars, something that they're all able to do a little bit differently than perhaps the non-electric cars. Okay, here's a different one for you guys, and this one I'll be very impressed for anyone who gets this one. What's this car?
Scion.
Scion what?
XA.
X.
This is my car. It is not an XA. This is actually, my brother has an XA as his little sidecar, like his little like travel around the city car. This is a Scion XD, right? And here we can see many differences. And I like to say that this XD here really represents me, because it's like a, you know, like a smile the other way around though. Yeah, this is actually my car, and it is actually in red. It's a 2011, but I take care of my car, so it's still running. Maybe missing a hubcap or two, but that's okay. But we see differences, right? We see some clear differences between this car. I think you would all agree that this car is not electric, based on what Randy was telling us, letting the air in and out. But I get good mileage with this car. And when we still get good mileage and we think about everything that this car does, you can say so much about physics just with this picture alone. The biggest part of the physics in here is happening all in the interior. Can anyone say anything about physics that's happening in this car? Anything at all? I'll give you guys a minute.
There's a coefficient of friction on the tires on the ground between the concrete and the rubber.
Oh, okay. So Randy says that here between the tire and the floor, there's a coefficient of friction. And this is the variable mu that represents the coefficient of friction, or you could also do a little f. That's a really good one. That's a deep one. We won't learn about that until next week, at the end of next week. And someone says that they thought I was more of a Mercedes type of person. I don't know. I did want the Lexus for a while. Like I like the what is it? The hybrid, the RX 450. I like those, but I don't know. I can't pay for luxury. I mean, I can.
You live
but
downtown.
Yes, what I should say is I can, but I don't want to. not for the car. For living and for Zoom, fun fact, I moved during the pandemic because in my old apartment, people were doing work from home, and all you could hear in my circuits class was reggaeton in the background when people were working outside. It was really hard to teach, and I was like, oh my gosh, I gotta move. Okay, and I see another force coming at me through the chat, a downward force acting on the car by gravity. Very good. And this is great because the two that you guys are describing, the two forces that you know are somehow there, don't necessarily have to do with motion. And this is really clear because motion, although we don't see it, is always happening around us. And when motion is active, then and things are moving, then you can say there's some velocity or acceleration. But when things are not moving, there is still motion that we cannot see. And Nate brings up a good one that I was really hoping not to forget. He says the engine works through chemical processes which are bound by, I think, physics. And that's all here. And let me tell you, Nate, all of that is physics 102. All of the engine work and the chemical processes that we're going to see that are happening in the engine are the beginning of physics 102. The first 4 weeks in the spring is what we'll do. We'll actually look at an engine too and look at the all kinds, the Stokes and everything and how they're moving.
Is that thermodynamics?
Yes, it's thermodynamics.
Okay,
That's exactly.
I thought so.
Yeah, and so what you'll see inside is heat, right? And what is heat? Heat is actually a type of energy very similar to the energy that we would use to move this car, like the power needed to move this car. Or on the other side, you see where I would put gas in this car. And here's a question for you guys. If I put 10 gallons worth of gas into this car, am I going to get 10 gallons worth of distance?
No.
Keon says no. Where are the other 10 gallons going to go? Where are they all going to go? If not,
There's it's inefficiency lost to heat.
yes. So that's another one we'll see on week 3. So in Physics 101 in week 3, we'll also talk about different energies. When we cannot describe how something is moving, right? But we can describe that something is happening, like we're putting gas into the car. That's a physical act. We're putting potential energy into the car, and then that energy is going to be transformed in many ways. One of which will be kinetic motion, and we'll get actual distance. But we won't always get all the distance. We will get heat loss through the engines. There's another big one. Any ideas out there? Another big one that we lose when we turn a car on?
Wind resistance.
But what about something that the car does?
Converting that one type of energy into another?
It is going to convert. That's right. And it's going to convert into at least 3 types of energy. Kinetic movement, we're going to have heat loss, and we're also going to have sound, right? When you turn the car on, you hear the engine. Yeah, that's a mechanical wave, just like your alarm going off or an earthquake or an ocean, things like that. That takes energy away from the potential energy that we put into. So in week 3, that's what we'll look at. We're going to go from looking at motion that we can see over distance, like something moving some distance. I'll get to you in a second, Randy. Moving some distance to then things that we cannot see moving, but we know physics is happening. That's the energy of a system. And then we're going to kind of put them all together. So imagine when in week 4, when we have systems that are now colliding and hitting each other, right? You're going to hear sound, you're going to hear metal, warping and doing flying, and we lose mass. So we want to be able to still calculate for those situations, and looking at the energy of a system and its motion will let us do that. So all of this has physics, and all of this will take us from Physics 101 and then finally into the engine and into the electrical components in Physics 102. And Physics 103 will be things like looking at how we get this light, looking at how we get the transparency through the window, or what about when you look through your side view mirrors and your rear view mirrors, and it has that little thing that says, objects may appear closer than they are, or something like that, right? That is all optics and all physics. And those are what we call uh, imaginary objects. And you can solve for that. What is the actual distance of that imaginary object? I think Randy had a question, and then maybe someone else, maybe Isla. I don't know.
So you said that sound is like a loss of the energy. So I know that upgrades to your exhaust can increase your fuel efficiency. So is that to say a louder car is less efficient than that same car with a quieter exhaust, or a quieter
That's a good
quieter
relation.
version of that?
Yeah, that's and let me also reference it in that we're talking about a loss because we what we want out of the engine is for it to move us, right, as much distance. So that's why we say the word loss. But in like a science physics way, we're really talking about energies being transferred to different types of energy. And so yeah, if you have a louder car, you're going to have a different amount of energy used for that sound, that mechanical wave. And so the energy is being transferred elsewhere. But ultimately, if you put in a certain amount of potential energy, that's what you have. And you guys have probably heard the statement, energy can neither be created nor destroyed. It can be transferred, and that's what happens. We take our energy and we move it in all different places, and that's where you get your efficiency. So the first statement we got from Keon about the car not being as efficient, in fact, mechanical cars have a very low efficiency, right? Yeah, it all gets transferred, and our goal is to examine what we see around us and try to pull any physics from it. And in physics 101, we're going to mostly focus mostly on things that we can see actually moving, right? Let me see, I got a question. I got a few questions. Let me scroll up really quick. Okay, more about the car. Having the engine, there's also an upward normal force. Yes, there is an upward normal force. So, man, you guys are really good at these forces. Probably if you took physics 11, right? The force of gravity is acting down on it, but why isn't it falling through to the center of the earth? Because a normal force is acting back on it, right? You could call it N or F sub N, or a normal force like this. And, we'll familiarize ourselves with this a little bit more. And I also see that having the engine in front versus having it in the rear of the car changes how it drives too. Yeah, you're changing the center of mass. And then Daniela also says the aerodynamics comes to the wind, comes to mind, which is part of fluid dynamics, I believe. Yes, the wind and how, oh man, for you engineers out there, fluid dynamics is like physics 102 for the sequence. Fluid dynamics is a course that you're gonna see a lot of as an upper division major, especially if you're like civil, aerospace, even mechanical, you'll see it. Electrical, maybe not so much. So computer scientists, not so much. But yeah, you'll see a lot of the fluid dynamics. The friction between the brakes and the brake paddles, absolutely. That's really key to the brakes working. And then someone to me says reggaeton in the morning is good for the soul. I agree with you, but my circuits class was in the evening. And I could not get through a class without the neighbors playing Bad Bunny like for an hour, and it's like, my God, I'm just trying to teach circuits. But anyways, we just hear sirens, I guess. Okay, and then next, if the car was moving, there'd be some air resistance. That's a really good statement. If the car was moving, there would be some air resistance. We're gonna see that next week. Yeah, we'll see that next week. And static versus dynamic motion. That's exactly what we're going to talk about. Physics 101 will mostly be dynamic motion. We'll mostly have things that have some speed, some acceleration. Sometimes they won't have any speed. And then we know that all the forces must somehow add up to zero. So when you see a building out there that's standing, right, it's not crumbling down, you know that anything that's acting on it, all of those forces must somehow add up to zero. Yeah, so motion will involve our first derivative and our second derivative. Yeah, we're gonna get those in soon. So as you can see here, that really what I want you guys to be most concerned with in this class is the physics that's happening, and try not to go too hard into some details, and I will always kind of pull you back into what we need for class at that moment. But definitely think about these things. And the more classes you take, the more you'll. I think that's a rooster. So the thing that you want to do is be that inquisitive physics student in in Physics 101, especially chapter 101. Chapter 1, we're gonna start throwing out all these terms at you, and we need to start applying those terms. See physics in action all around you and ask yourself, how does anything of that happen? Everything has an explanation, and our goal is to figure that out. And before we start trying to explain, chapter 1 is all about creating that language and the math needed to explain. So we're going to start with setting out what are units and how do we describe numbers, big and small, in physics. And again, if you've seen this already, I hope it just strengthens your understanding. Yeah, and I'll keep asking you guys how we're going through it. So if you go through the PDF and you look at our textbook, you'll see on one of the first few pages, or if you have the physical book, you'll see the front cover will have a page of conversions that's super useful, right? And the conversions, I hope you've practiced this in math before, you'll have practiced this week, helps us get from one set of units to another set of units so that we can all describe something in the same way. And there's like buckets of different units that we can use. The first one you'll see is length, right? Length to us is how far, what is the distance of something. And you'll see the units that we recognize: inches, feet. These are the ones used in the US. And then if you go around the world, you'll see the SI units. So you'll see kilometers, meters, and then smaller versions and bigger versions of the meter, the micrometer and the nanometer. But all of these are clearly lengths. What about this one? This is not a length like a meter. In fact, it's a light year. And this year is a time. Anyone know something about the light year? Why would it be under a length?
It's how long light travels in a year, or how far light travels in a year.
That's the perfect word, Amir. How far, right? How far. And that far part, how far does light travel in 1 year, is the distance that we need. Now, you should think about this. Why would we put something in terms of time that has to do with a length? And think about what's its purpose. And really, anyone out there know? Anyone? Ideas?
Because a wavelength, to like when you're working with wavelengths, you need to know, like you have a period, which is a time, I guess.
The
that it takes
period?
that.
Yeah, so it does tell us about the wavelength. It does tell us about the period. And all of that is true. Now, how easy is it? Oh, and Daniela says they're inversely related. Yes, they are inversely related. So that's good that you guys are making these connections. Now imagine saying 9.461 times 10 to the 15th meters is how far a light travels in a year. Whenever, perhaps in week 5, when we get to gravitational motion and we talk about things in astronomy, distances are huge. And so it becomes more convenient to say 1 light year instead of the distance 9.461 times 10 to the 15th meters. So this is very much something about like how practical is it to say this, right? So we would put this under this length, right? And we keep going here, right? We keep going, we see a bucket, length in 2 dimensions, an area. And then we look at length or space in 3 dimensions, we'll get a volume. And then we get to mass, right? Mass, the way that we know it is usually in pounds, but pounds isn't on here. We see kilograms, right? We kind of understand a ton. But if you look closer, you'll see, yeah, pounds is under approximations. Any guesses, guys? Why is pounds something that?
Because it's a weight.
It's a
Pounds
weight.
of force.
And it's a force. So when we look at pounds, this is something that in the US, when we talk about every day, we consider that weight, how much somebody's, what their mass is, right? Somebody weighs 200 pounds, you could say their mass in Europe or their weight in Europe would be, I don't know, like 350 50 kilograms or something. That's a lot. I don't know. Something like that. But if you look here under our very exact conversion page, it is considered an approximation and not an exact conversion. And we'll find out next week in chapter 5 that this pound, like you all told us, is actually a weight. And the word weight is not equivalent to the word mass. This weight and this mass are not equivalent to each other. Weight is in fact a force, right? And we'll find out later that the force is going to be the relationship between the mass that's in our body, the letter M, times, let me not use a dot because some of you guys know no dot products here, times that value of gravity that's acting on us at all times, right? So you'll see this next week. You do not need to know this right now, but I want you to know that there's a reason why this approximation is not under the mass. And you really want to think about that. And this is really where our physics begins, is questioning things that we see that do not seem like what we know, right? Why is light year under length? Why is pounds not under a mass but under an approximation instead? I think I have some color here. Yay. So this is where it all starts, right? This is where we're going to start questioning. Yes, and Isla says that mass is without gravity. That's right. Mass is independent of these forces that are acting on it. But we're going to see that there's a relationship there next week, chapter 5. Okay, so we see that these units and the numbers with the units really help us, have our reference for what is a length, what is 1 meter, things like that. So what is the foundational units that we need to describe everything in the world? There's actually only 4. There's only 4 physical quantities that we need to describe everything in our universe that we know. So if we wanted to describe anything with physics, with the physical nature of something, you need to make some sort of measurement about its nature, something about how it exists. And each of these measurements has to be somehow associated to a physical quantity. For example, a physical quantity is the length of the object. And there are only 4 of these physical quantities that we need that will make up every other unit that you've ever seen. In Physics 101, we are going to go through 3 of the 4. And the 3 units are going to be length, mass, and time. Every other unit will come from length, mass, and time. So we'll learn like the base units of how to make something else. For example, what I'm talking about is like the joule. The joule will tell us about energy, but the joule breaks down to length, mass, and time, kilogram, meter, second squared, something like that. And so we need to find, as physicists, we need to find what is the base unit, and what is some sort of consistency between units that makes a unit, qualified to be a unit. So these are the fundamental quantities that will describe everything. And these are the standards and measurements that need to exist for something to be a unit that we can actually use. So this is more of a history for the next 4 or 5 slides. And I'll tell you what to write down. Did you have a question, Keon?
Yeah, I was just, when you say there are 4 and you only tell me 3, could you just give us a little spoiler maybe?
So the 4th one comes in Physics 102. Maybe you guys can think. Length, mass,
Energy?
Oh, close to energy. We're close. You're in the right realm. Huh? Yeah, I think you both said energy. We're in the right realm. It's the amp. The amp. Huh. Yeah. The 4th one is the amp. Dun, dun, dun. And this will really describe electrons moving, right? So that's going to be a whole unit to help us get into electricity, into light, into waves that you guys were talking about. All of that, that's the 4th fundamental quantity. But I promise, Physics 102, I will remind you of this day when we talk about this. Okay, so how do we come up with these units? So first, they must be readily accessible, meaning anyone in the world should be able to somehow get access to the fundamental quantity and what is the reference for that. It must possess some property that can be measured reliably, so over and over, and have the same value. It should yield the same exact result each time, and it shouldn't change without time. It shouldn't change throughout time. And these are the things you'll see that throughout the world, we've come to realize little by little, right? So why we were able to get a good grasp on time, because we use the sun, right? And the sun doesn't change without in time. But if you try to use something else, like the amount of, how long it takes me to run a mile, and use that as like a unit, that's going to change over time for sure, right? So here's what it looked like around the world throughout time. Our unit or our first fundamental quantity will be the length, and the length will be described as a distance between any 2 points in space. So the first real unit of length, and this again is just historical, you don't need to write this down. The first unit of length that was used commonly was the yard, and this standard of course came from the King of England, and here is how he created the unit of the yard that was used by scientists at the time. He took the distance from the tip of his thumb to the tip of his nose and called that the yard. Now, does that change over time?
Yes.
Yeah, fun fact, your nose actually gets larger over time. And who knows, maybe his reach could change, right? So up until that time, it was the yard, and we've heard of the yard. Before 1799, the French said, we will not use the unit from England, and we will use the standard of the foot. And yes, that was the length of the foot of one of the Louis, King Louis the 14th, I think. And so that was it. And then after 1799, we needed here some and Nate says it's strange that we still use some imperial units and not metric. Yeah, and it all comes out of the length that we're using. What amount of length is it, and what unit makes sense to use? But the science people started to get with it a little and figured out that you need some sort of consistency. So after the French royal created his standard, the standard across the world finally became the meter. And this is our SI unit, around the world. And this is a French word. If anyone out there speaks French, standard, system, and something international. It's in French. Anyone? No one? No one, okay. But SI, System International, but French words.
System International. Is that what you're asking?
Yes, thank you, Kia.
Okay.
Yeah, it's somehow French. So that's the actual standard, and here's how they came up with it. The distance of the meter, and again, you don't need to know this, just kind of fun fact, is 1/10,000,000th of a distance from the equator to the North Pole. All right. Now that was pretty accurate, and it became even more accurate with the discovery of light. So at the end of the 1800s, going into the 1900s, when electricity really kind of led to more discussion between like light and the atom and how to measure light. Then we got an actual more consistent measurement of the meter, which is associated to the speed of light. So the meter now is defined as the distance traveled by light in vacuum during a time interval of 1/300,000,000th of a second. And some of you might recognize this number. The speed of light is actually 300 here. It's approximately, this is approximately 300 million, or you might have heard 300,000 kilometers, or 2.99 times 10 to the 8th meters per second. This is the actual speed of light, meters per second. So in 1 second, it travels 300 million meters. Or if we invert that, then 1 meter will be the distance that light travels in 1/300,000,000th of a second. And so that's the distance. And here's the stuff that you want to write down for this slide. Anytime we talk about length, Anytime we talk about length, we will use the unit of the meter, and the base unit of the meter will just be 1 meter, and we will always use this letter M. So this is very important. Notice that it says length, and right next to it you have the unit there. And so we have the distance in meters of all of these different values here, and you can see how it changes. So for example, a football field is 9 times 10 to the 1 meter, which is 90 meters. I think Nate said it, right? We still use yards. So like 100 yards for a football field, I think kind of rolls off the tongue a little easier than saying 90 meters and trying to divide that out. 100 is a little bit easier to divide through. And, you know, that's kind of where it comes from. So you see that these distances going up this way are incredibly large. And you might even ask yourself, how do we measure the distance of the observable universe? We'll get to that in week 5. How do we actually measure this once we've come up with a lot of relationships? And then you see some lengths and some distances that are really, really small. Oh gosh, no one told me it's already 12. I'm gonna have to go really fast. Let me set up a timer. Okay, guys, give me until 12:30. I know I said 12 to 12:30, but let's go 12:30 today, and then I promise I'll let you go. Okay. Okay, so small distances. We see much smaller distances here. And the thing you really want to pay attention to is notice that as we describe these lengths and these meters here, you see these numbers, right? These numbers that help us describe how big or how small something is. And so that's the next thing we really want to focus on is these powers of 10 and these numbers, symbols, and prefixes, which is just a nickname for it, that help us describe kind of the intensity of something. The word we're going to use is the magnitude. How big or how small something is does not necessarily tell us about the physical nature of it. The unit tells us the physical nature. The magnitude is given to us by the power of 10, or the number that you see. So this tells us magnitude, how big or small, or the intensity of something, right? And this is just the number. And this tells us about the physical nature of something, which is the length of a distance between 2 points. And this is the meter, right? So our meter here. And so you want to know this, and I hope to come back to this slide in about 3 slides. We'll see these powers. You're going to want to be comfortable with the powers of 10, the prefixes of 10, and all of their abbreviations. And by the end of this class, some of these will be you'll just kind of know them like everyday language. But some of them you need to memorize. Some of them you do. And I will tell you which ones they are. Okay, so that's what we have for length. The next fundamental quantity is mass. And mass is not, again, your weight. In physics, we have 2 definitions for mass. We're going to start with the first one that'll stay with us just until about next week or so. So the mass of an object will only be the amount of material present in that object. So the reason we say the amount of material only in the object is because once we start in future classes, you look at the atomic structure of something. And if you've ever just looked at how atoms are drawn, right? They look like they're drawn like these circles with connecting lines. Well, these connecting lines aren't really there. Those are forces, electrical forces that you don't really see. Oh, I think my cube is not going to work out here. All right, well, that's a cube. Keon. So what we would count as the mass in this atom is only the mass of the atom itself, not everything connected to it, right? So if we look at a molecule, a long string of atoms, only the mass in the atom, not the spaces between them, would be there. And so that's what we consider the mass. And so any object you look at, if you have a microscope, a really, really good microscope, you'll eventually see that there's actually a lot of air gaps there. Yes, Nate.
Oh, those spaces are those account for the density of mass, right? Or matter, like depending on how far away the atoms are from each other in like a crystal structure.
Yeah, that's exactly right. So what I just drew up there is a crystal structure, and what Nate said is the density. And so density is mass over volume. When we look at, is it mass over volume? I think so. Yeah, if I'm wrong, just look in the textbook. Oh, Bradley says yes. Sajid says yes. Thanks, guys.
That's mass volume or mass density, and then is there like weight density or something?
Yes. Yeah, there are those. And so just really quickly though, the differences here is that this density takes into account the volume. So this density would look at how much of matter is filled versus the space that's available there, right? So how much matter is in the entire volume, um, whereas the mass would just be the actual space that's here. One way to think about it is like if you take this is something that I had. You guys are gonna think I'm so weird, but whatever, it's okay. Um, I had this from a previous meeting that I had. Let me take my background off. So here you have a cup of frijoles negros, because I'm from Guatemala, everyone, in case you were wondering. So here you have a volume of this cup, and the cup can hold a volume of, I don't know, let's say 100 cubic centimeters, something like that. But the mass of the beans would not be equivalent to this volume of this cup because there's little spaces in between the beans, right? So these beans are like the mass, and the weight and the volume of this cup would be everything as a whole. So this is a really good example actually, because there's a lot of air gaps in here.
Are we saying then that the weight of the air is negligible? And that's why when we measure like gases, we have to figure out all the substances because they're rarely pure?
Yes, that's exactly right. And usually I would ask you for the mass of the beans. And so if I ask you for the mass of the beans, then you have to consider what is the material that it's made out of. And this is really deep, guys. If you are at all interested in this kind of stuff, take materials of engineering. I know the instructor, it's me. That's actually what my PhD is in. It's in materials of engineering. So this, I could go on forever, so I'm going to stop here. But yes, crystal structure, density of materials, all my vibes. When we talk about mass in this class, it'll be the amount of the material, not the space, but the material itself, and what is just the inherent like material that we are looking at, nothing else. In the future, like in 3 weeks or so, we are going to change this definition of mass to a physics definition of mass. And the physics definition will be how much that object resists changes in motion. And if you've taken physics 11, perhaps you heard the word inertia before. And the word inertia is the rotational version of this resisting changes of motion of an object. So I will walk you through this a little bit next week and in the third week, how an object resists changes in motion. And a really good way of thinking about this is ask yourself this question: which would you rather catch? If a bowling ball is thrown at you or a basketball is thrown at you, which would you rather catch if they're the exact same size? Many of you, except for some of you brave souls out there, will say the basketball. And there's a reason. And there's a reason for it because it has a lower mass, right? All of that is related. That lower mass, it has a relationship to how it's going to accelerate through air. A basketball is going to easily move through air. So it's going to have a low resistance to change. And Nate brings up a good point. How fast are they moving? In this class and in all science, we're going to keep all variables the same until one by one we start changing them. I got you, Nate. So our definition for mass to start will just be the amount of material in an object. So what is the mass? An inherent property of an object, basically made up of the atoms that are in it. And this mass is completely independent of the object's surroundings and of the method used to measure it, because it's completely unique to that material. It truly, if you want to go deep into this, it truly depends on the atomic structure of the material. And as a materials engineer, I argue that that is the key to everything. I think I'm right. Okay, so here are some masses around the world. You'll also see More examples again. The big thing you want to pull from this slide is that the SI unit of the mass is the kilogram. Notice that you probably recognize the gram, and then you have this K. This K is the kilo, and I'll show you in 2 slides. We'll probably stop after that significant figure slide or the powers of 10 slide. But I'll get to that. So this kilo gives us another power of 3. So 1 gram, 1 G would just be 1. A kilogram would be 1,000 Gs. So all of this, you might say then, if I say 10 to the 52, it's really 10 to the 55 grams. Yes, that's correct. This kilo adds another 3. But usually it's easier to describe things in kilograms versus grams. It'd be very small. And you can see here why. The human and, you know, an average shark weighs about 10 to the 2 kilograms, right? So 10 to the 2 kilograms, about 100 kilograms or 10,000 grams, which is a little harder to say. But you see that pretty much anything past the human, which are very common masses, is more than 1,000 grams. So it's easier for us to use the kilogram, and that is the SI unit around the world. And here is how this is measured precisely throughout the world too. This was created in 1887, and we use a specific material, a platinum iridium alloy, and this is a very, very stable material. Not so common to be stable if you're a pure material. This is an alloy, and once an alloy means it's different materials mixed together. So imagine if you have a material with imperfections, you mix another material in to help cover those imperfections, and you can gain some stability there. So a very precise sized cylinder is kept at this place, the International Bureau of Weights and Measures in France. And there are replicas all over the world, usually about 6 major replicas all over the world, and then replicas of those replicas. And so our replica is kept, I think, in Washington, D.C. or in Virginia somewhere, the National Institute of Standards. And then a lot of the Army bases, the Air Force bases, have them across the US. And the one local to California is in Corona. If anyone's ever been out there, I actually got to travel. I got to go to this lab as in another job and look at these. And in those labs, the way that they measure things is not by scales, but by using little cubes like this and kind of matching up the masses of them with many of these cubes. But it's replicas, all replicas of these. And notice that they're kept in like containers and in vacuum. Yeah. Okay, fun fact, and I shouldn't talk too much more. This changed in 2018. If anyone here on Twitter, it was a storm on Twitter. Yeah. This value changed in the micrograms, and micrograms is 10 to the negative 6 grams. And so you might think that a digit 6 spaces over maybe wouldn't make a huge difference, but it actually made a huge difference when it comes to any atomic calculations. Atomic calculations are usually 10 to the negative 9 and smaller. So anything 10 to the negative 6, which is bigger than that, is going to make a huge difference. And this gram is an embedded unit in what when you guys all say forces, the unit of the force is the Newton, and the Newton is kilogram per meter per second squared. So it changes things in that.
Why?
Huh?
Why did it change?
I don't know why it changed. The material itself changed over time, and
Oh, so this material changed, but not our actual weight, or not our actual mass.
Well, here's what I think happened. And I think our measurement techniques got better and they improved. And when our measurement techniques get better and we figure out like we can more precisely get a measurement, that's probably where that negative 6, that microgram number changed. So perhaps the material didn't change, but probably our measurement technique did. But I don't actually know why. That would just be my best guess.
So like if I were to buy like a diamond, or if I were to buy gold, I would be buying more or less of it now, and that would make the value of what I currently have less or more now?
I don't think the standard has trickled over into our everyday world of buying things.
Okay, so scientifically then.
Yes, it very much
Okay.
makes a difference in some known constants. I should figure that out, which constants it actually changed. Yeah. Yeah, micrograms are very, very small. They are super small. So, but there are some numbers that it changed. It took the Twitter world, like, it went crazy on there. I was really excited to see that it actually made it change. I think it happened 2018. Someone can look that up. Let me see what else I got here. Okay, and this again brings us to our back to our conversion, right? That the kilogram is a unit of mass, but the pound is a unit of weight. And so that's why we have that approximation there too. Keon says lysergic acid is dealt with in micrograms. Ah.
It's just a very potent compound.
Is that LSD? No.
I'm gonna move on. Yes, guys, make these connections. Okay, our last.
So like if,
Uh-huh.
to go on that topic, like are medications now, like are they changed like as far as what a patient is prescribed? Because like there's medications that are dosed in the micrograms.
Yeah,
At doctors and nurses' offices, things.
I don't think so. That's a really good point, and I'm not 100% sure, but I don't think so. I don't think it's made a change. Um, no, I don't think it's made a change, but it would be something to look at. Maybe something to Google after this class, guys. Um, Let me just put my timer back on. But that is the type of effect it should have. It should have that type of trickle effect, Randy, where if one conversion and one variable is changed, one constant, we now have a new constant of mass, it should, have an effect on everything else eventually.
Because then like people communicating, sharing information, talking, like they would eventually come to issues.
Yeah, and I think that would it would also take some time, right, to apply this. But you're absolutely right. It does have an effect on things, which is why it actually made the news. The microgram actually changed. Yeah, but I don't know. It would be a nice Google search to do though. And Nate says, I remember I was in chemistry when they changed it and we were learning about Avogadro's number. Okay, that's somewhere too where we would actually need it. I think it would probably just change a digit, right? Yeah.
Yeah, my professor had no idea, and I just thought it was funny that like I saw it in the news and we were just learning about that. So
it's physics. Those chemists, they don't know. Physics. Don't let them tell you that chemistry is not a part of physics. It is.
yeah.
Okay. Uh-huh.
Never mind.
Our last fundamental quantity until we get to physics 102 is time. And so time, of course, was measured with something that we could see very easily. And early astronomers, all they did was look up into the night sky, right? And things that they could see were our sun and 6 or 7 of the closest planets like Jupiter, Saturn, sometimes Mercury and Mars and Venus. So the sun was the one that they used, and it was literally the mean solar day and the second all came from this measurement of when they would see the sun in the same position in the night sky or in the daytime sky, right? And it would take 24 hours, and then they cut that down into different increments. So our time unit is the second, and the first measurement of the second came from the mean solar day. What's the average time it takes to see the sun in one day? And so one day would be the 24 hours, 24 hours in a day, 60 minutes in an hour, and then finally 60 seconds. And that all comes down to just increments and the circle and how that gets cut down. It's kind of interesting. It's kind of interesting to me because the mean solar day and all these values really come up with like just practicality and how we use it, because you guys have probably heard this, that our day isn't exactly 24 hours. It's like 23 hours and like, I don't know, 57 minutes, something like that. Yeah, if you haven't, Google this too, the mean solar day. It's actually just a few minutes off, but for practicality, all these numbers get kind of rounded up, and we don't really see these effects, at least for hundreds of years, right? So it's okay to make some of these adjustments here. The actual standard for the time then came from the atomic clock. And if you ever want to have the exact time, buy yourself one of these atomic clocks. They're all measured against, I think in the US, they're measured against the atomic clock that's in Colorado. And so this came from the vibrations of cesium. And if you remember any of this from chemistry, you know that atoms and everything around us, they're moving at all times. But they're moving in a very precise and exact way. And you can measure this, right? Because you have a specific length here, and you can measure the time it takes to cross that vibration, that length. And so the amount of time that it takes to cross that length can be very consistent and very precise, and also very hard to measure. And so this is the type of measurement you would see in a university or a research lab, where they would take some chamber, ultra high vacuum chamber, a UHV chamber, that lets them pull not you know, like all vacuum, but very low vacuum. So if our everyday pressure is something around like 700 torr, that's the unit of everyday ambient air that you see right now, they're pulling something like in the millitorr, like much lower than that, like 10 to the -4, 10 to the -5. And they're pulling out all of the air from this to try to slow down anything that is moving in the chamber. You also do this, of course, like where you can isolate the system. So like deep underground in either 2 levels, 3 levels of a basement. And you also cool it as much as you can to try to also slow down any movement that you have there. And so what you would see, the way they would actually measure this is that they would be able to isolate some cesium atoms, and then they would shoot it with a laser, and you see that the laser has some signal here. Well, once the laser hits the atom, and now the atom vibrates differently, when it hits the cage, some type of metal cage, a new signal will be transmitted out, and you can then pull out the original signal and measure what is the new part of that signal to figure out what are these vibrations, right? And waves here can, of course, be translated to waves there. And so our actual unit of the second then is this large number times the period of vibration, the period brought up from you guys earlier, of this cesium atom, right? And so you might think like, well, okay, this is how many times the cesium atom vibrates in 1 second. Hundreds, thousands, millions, billions, 9 billion or so times in 1 second. Okay, I have a minute left, so let me just keep going here. Okay, so then here's the important part of this slide. The most important part of this slide again, and like in the last ones that you saw, is that the unit of time will be the second. The second is our interval here. And again, like in everything else that you saw, you see a physical description with the unit of second, and then you see a magnitude of the description with the number and the power of 10. And so we can count, for example, 1 day is 8.6 times 10 to the 4th second. This one is kind of useful, right? 3.2 times 10 to the 7th seconds in 1 year. That's how many seconds there are in 1 year. You can calculate this with several conversions. The last thing I'll leave you with, because I'm at the minute exactly, is this powers of 10. And this is where we'll start again tomorrow. We'll start with the powers of 10. And here are the ones that you really want to know. And have these memorized. Definitely something to put on your equation sheet. You know, things that you want to talk about. You also want to be able to differentiate between when someone asks you for a power, when someone asks you for a prefix, or when someone asks you for the abbreviation of a number. Abbreviation, you're going to use, you know, the micro, the nano, the milli, or the centi in its symbol form. So this was the symbol. And the prefix is like the nickname. So sometimes you'll see someone write nanometer, right? Or you'll see someone write milliseconds, and that's really fast. Or you'll get asked for the number in powers. So something, you know, 5 times 10 to the -3 milliseconds. And 10 to the negative 3, this 10 to the negative 3 replaces the milli, and you just have to write the second. But I'll go through that more in detail with you tomorrow, how to write it. But these are the things that we really want to know. Now, I'm going to stop here just because it's 12:30, and okay, let me just stop sharing the screen so we could talk for a second. You can finish these slides. They're available on our Canvas, and I will walk you through Canvas probably first thing tomorrow morning. But oh yes, and I will get to add codes, but I will officially just stop lecture in a second. The homework and the lecture slides and even the lab is all available. You can start it, and you probably should start it, at least the homework and the review sheet. But I will go through it in detail all tomorrow. But take a look at it. I think you could start a little bit of it without me having to introduce it, but I will introduce it all tomorrow. So, you know, officially do something worth like 4 to 5 hours today. And I recommend the review sheet because you can work on angles, and that's kind of fun. And I also recommend that you either look at the slides or start reading a little bit of chapter 1. Yeah. But we'll start with this tomorrow. We will still have time to finish chapter 2 because, you know, we have at least 2+ hours, so we'll be okay. Before I officially stop hitting record and finish lecture, can I get any questions from you guys about lecture or general topic ones?
Yes.
Go ahead.
For the slides, I saw that some of the stuff is blocked by like your special notations. Is there a way you can do it to where it's not blocked anymore?
Yeah,
like you're writing,
all you have to do, Bailey, is download it.
and then it won't have those annotations anymore on it. And then
if you download it and open it on PowerPoint, you should be able to see it.
Thank you.
Yeah. And then in preview, it's always going to be a little funky, but if that doesn't work, just let me know, because I could put it up as a PDF, but it might not be as easy to view either. But just let me know. But download it and open it in PowerPoint. Yeah, thank you. Randy, next question.
So like if we, to start this stuff, if we go on to, for the whole semester, every teacher kind of does it differently on Canvas. So is everything we should do by the day, by the week, by the whole course on the module section of our page? Like, so if I go through the module where it says day 1, I should be able to complete everything from that.
Yeah, the module is updated in this class by exam. So by exam, and ours is exam per week. So every module will cover 1 week. Right now, all you see is chapter 1 because that's all we've done today. But by the end of Wednesday, you will see the assignments for chapter 2 and for chapter 3. But yeah, the module will cover 1 week, and the module will also cover 1 exam completely. So 1 topic of exams. And that's also how the syllabus is broken down.
And like exams will also be on the modules.
Yes, okay. You'll see on Thursday, here's a little preview. On Thursday afternoon, after class, I'll also put in a document that says exam resources, like things that you should use to study for the exam. And then when you actually take the exam, the link will be available at the very top of the module. I'll make it very obvious that that's where the exam will be.
Okay. Thank you.
Yeah, no problem. And I got another question in the chat. First, I very much will pull up the ad codes. And then the second one, the homework and labs are due Friday before midnight, correct? Yes, the homework and labs will all be due Friday by midnight. And the goal of this is so that you can spend the weekend only studying for the exam. But can you turn stuff in late? Yes, you can. Any other questions, comments before we?
Yes. Hi. Yeah. For homework, do you do like example problems in class, or is it like we kind of do it all on our own when we start?
No, we'll do example problems in class, and I will say that the textbook problems are always a little bit harder, and sometimes they're a little bit more out there. One student once put it as it's like you're going through these math acrobats to try to solve the textbook problems. So the the textbook problems, they're meant to just to get you become resourceful, learn how to set up problems and work through them in detail. And the book is also really good at kind of taking you through examples and then the homework. And my examples will be those of the textbook also. Yeah. And then I'll just throw this out there really quick that you might ask yourself if the exams are like the homework problems, but the homework problems are really long. That doesn't make sense. That's correct. The exam problems will be a shorter version of the homework problem.
Thank you.
Okay. Any other questions? Feel free.
I'm sorry, one more. I've never taken I think you guys took like there's a prereq kind of like physics 11 or something that people have taken with you. I've never taken that, but I've taken the whole calc series. That's not going to put me at a disadvantage.
I accidentally muted because I was trying to wipe my keyboard. Can you repeat that?
So I haven't taken any previous physics classes, but I have finished the whole calc series. Is that going to put me at a disadvantage by not having any previous knowledge or anything like that?
No, it won't be a disadvantage. And I only mention the Physics 11 prereq because so many students in the class right now are not from Trade Tech. But let me be clear, at Trade Tech, which is the school that I teach at and the school that is offering this class, there is no physics prereq for Physics 101. The only requirement for this class is Calc 1. So I will teach it in that style. For those who did take Physics 11, you might just be very familiar with some topics, which is why some people probably said the normal force and gravitational force and frictional force. But if I ever seem to be going a little too fast or you need some clarity, please stop me and remind me. Yeah, but you should be okay. I will teach the course as if you've never taken Physics 11, and I hope it's meant to be taken without Physics 11. So it should be okay. Yeah. Any other questions? I see one for me. So I can't take Physics 38 from LA Mission College after this course. I don't recommend it. If you're very hard, if you're set on that, then you got to talk to some counselors from both schools, including the school you want to transfer to. But I don't recommend it. But yeah, I wouldn't do it. Yeah. Any other questions, comments? Okay, we've had quite a few questions over 12:30, so I'm gonna end here, and I just extra want to thank you guys, and again, I'm incredibly grateful for how engaged you all were today, and I hope to continue that the entire week. I don't know if you guys all felt this way, but I was incredibly nervous yesterday and today, and I've been teaching for a long time and it never goes away. But the minute you guys start talking, it goes away. So I really, really appreciate you guys engaging. I hope we continue it the whole semester. I think you'll see that it makes a better experience for all of us. So I'm going to, yes, Daniel, I'm glad you're excited. I am too. I am going to officially stop recording, but I'm not going anywhere. I'm going to stay and do all the ad codes and any other questions, but I'm going to stop recording. Lecture's officially done. You're all free. And I will see you all tomorrow morning at 10 a.m. on the dot.
Thank you, Professor.
Bye,
Have a good
Kian.
day.
You too, Kian. Thanks.
Thank you. Have a good day.
Thank you. You too. Bye. Okay, I'm gonna just hit stop recording. Bye, Daniela. Bye, Noah. Bye, Esmeralda. Bye, Saja. I hope you have a good day too. Bye, Hafsep. Okay, let me stop recording. I don't know where that button is. I found it. Bye, Luis. Bye, Sanjita also. Bye, Brian.